Ready. Good morning, good afternoon, good evening, everyone, depending on where you are in the world. I'm James from Dora Hacks, and I'm delighted to be welcoming you all to the first workshop for the Grant Factory Hackathon with Taiko, the first workshop. So I will hand over now to Joran from Taiko to do a quick introduction to the hackathon, and then we've got a number of speakers to take it away with the workshop.
Thank you so much, James. Super excited to be here. We're kicking things off with a bang, and we're going to have a couple workshops back to back. First up, we have Javier from Goldsky, and then we're going to have the Hemera, a couple folks from the Hemera team come on and do a workshop for you guys. If you aren't already aware of the Grant Factory, it is Taiko's first major dedicated hackathon since we went mainnet. And so we threw up 100K in prizes on top of whatever all the bounties that Goldsky and Hemera are putting up as well. And there might be some secret ones still being worked on coming down the pipeline. Yeah, so this is an opportunity for people that have great ideas to start their careers by deploying their projects on Taiko, and people that already have robust careers to bring those and expand their business into the Taiko ecosystem. And we want to really support businesses that are looking to build long-term in the space. And that's what the whole premise of the Grant Factory is. So at the end of the Grant Factory, we hope that you have a project deployed to Taiko and you have a grant polished and ready to submit to our grants committee so that you can first of all, win an initial prize from the hackathon, and then also win additional funding for your business to continue to grow into the future. And so without further ado, let's get into our workshops, and I hope everybody enjoys. Off to you, Javier.
All right, cool. Thank you. Let me present the screen here. Okay. All right, 1 second. Okay, cool. Well, actually, before we do that, let me share this with you so that we can have it, everyone can just see this, because there will be some links which are useful here. I'll share it to the private chat, if you can share it around. All right, and let me start now. Cool, so the presentation today is called Indexing and Streaming Taiko Data with Goldsky. Before we start, I just want to give a little intro about myself. My name is Javier Trujillo. I'm a solutions engineer here at Goldsky. And well, this is my contact details. So the reason, or let's say my main duty here is to make sure that everyone understands the value proposition of Goldsky and also gets hands-on on the products. And if you guys have any questions, feel free to reach out directly on my Gmail account or Telegram. But if you have any general help, you can reach out to us on the support@goldsky.com so we can triage your case and pull up the appropriate resources. Now, before we start, I want to just call out the fact that I'm not a subgraph expert. I definitely know quite a bit of things, and I'm going to make sure to share those with you today. But subgraph technology is quite developed to this point, and so it can be a full expertise by itself. What that means is that we want this session to be as interactive as possible. So if you have any questions that I cannot answer, I'll make sure to write those down and follow up to you later when I got an answer for that. Cool. All right, so this is the agenda. First, we're gonna start with what's indexing and why it's so important, and then we're gonna see how Goldsky fits into that picture and how it fits into the evolution of on-chain data retrieval. So first, we start with the basics of indexing. Then we go into subgraphs, what the relationship between these two is. And then we get into more kind of what I like to call the fun part of it, right? Which is more the practical part of the session, where we're going to be deploying subgraphs onto Goldsky. First, doing the standard development process, which is basically the one, for those of you who are familiar with the graph, it will be the exact same process than using the graph CLI. as I want to show you guys how to do the standard development process first, and then once we are familiar with that process, then we can switch into how to use what's called Goldsky instance subgraphs, which is a very unique feature we have where you are pretty much able to deploy subgraphs onto Goldsky without really having to program or do much coding other than providing a config file. So it's a very convenient way to do it. Once we go over that and over subgraphs, we're gonna get into what's next in terms of indexing, right? And this is what we call Goldsky Mirror. Goldsky Mirror allows you to create real-time pipelines to stream the data that is in this subgraph technology onto your own database, which is also pretty cool. And I think it's you guys are gonna like it a lot. At the end, there will be some time for Q&A, but I think I would like it if you guys have any questions now that we are live, feel free to post them on the comments, and I'll make sure to address them as we go. Okay, cool. Let's get into that. Okay, cool. So why indexing is important? Historically, or if you look into the way we index data from the blockchain or read data from the blockchain, is rather inefficient. If you just look at how blockchains evolve, right? A blockchain by itself, as we all know, is a continuously growing list of records, right? Of blocks. If you just zoom in into just one block, right, you'll realize that there is a ton of information in it, right? There's going to be data about the transactions on the block, and that will be transaction receipts. It can be the gas that is being used, etc. Within it, there will be logs from all the events that are emitted by the contracts that have been participating in that transaction. There will also be traces from all the calls that will be between contracts, etc. And there's a ton more of it of data within just one block, right? So as you can see here, the growing list of records can get huge if you're just like reading through it in a very reactive or passive way. And this is exactly what we have been doing back in the day, right? Originally, the way that we were retrieving data from the blockchain, it was very like in an ad hoc kind of reactive manner, where we were relying on ETH RPC calls directly, or maybe doing contract calls to public methods of those contracts. And in a way, that's actually very inefficient if you think about it, because basically you are you have a client that is continuously calling these methods reactively. And whenever it needs data, it will just call up the blockchain, right? And if you think about it, it just can take or put a lot of pressure on the client side. And here, I don't know if you can see this, but here I'm trying to show an example that we ran before one of the tests that we did, where we were following this approach. And in this simple example, we were trying to display just like a collection of 20 NFTs, right? And these took like 41 network requests to get the data, just to render that page, 41 network requests, and it took around 10 seconds. So this is very inefficient because one, puts a lot of pressure on the client side. It also put pressure on the nodes because now the nodes needs to serve the requests. And then in the end, it all translates into a pretty bad user experience because you're basically waiting 10 seconds to get to see that data. So if we want to really get to a Web 2 kind of user experience, we need to progress to better technology. And so in that regard, indexing came as the most obvious of a natural solution, right? What indexing allows us to do is to create a separate off-chain database that essentially scrapes continuously the information that is coming in the blockchain as it arrives or as it is produced. And the advantage of this is that essentially we're now able to scale and run optimization on the data layer separate from the blockchain. So this allows us to have the data in a way that is more structured and in a way that allows us for more complex queries. You can think about indexers to be like pretty much blockchain scrapers that are getting that data all the time and putting that into a separate database, pretty optimized for data retrieval. Today, indexing is essentially what really powers the Web3 in terms of the user experience, right? Like any page you go, that's going to be index powered in some way by one technology or the other, be it for trading apps, be it for analytics, maybe for gaming, etc. Today is a de facto way of on-chain data retrieval. Now, what's the relationship between indexing and subgraphs? Essentially, subgraphs are the most used indexing technology today, right? In subgraphs, just like in the indexing technology, what they do is that we will scrape data. There will be indexers that continuously scrape data, get that data and store it in a Postgres SQL database, and then offer a GraphQL endpoint for you to be able to query that information in a way that is convenient for you. Now, subgraph technology was originally developed by the Graph. So we have our own Goldsky subgraphs, which are fully compatible with the Graph because that technology is open source. Plus, we also ran some or added many optimizations on top in terms of the query performance, in terms of reliability, support SLAs, but also we added other features that make the development experience a lot better in terms of, the instant subgraphs that I mentioned before. We can also add webhooks to it, tags. We can also load balance between different indexers, etc., etc. And today, I'm going to be covering some of those later, so you're more familiar with it. All right, cool. So now we can get into the practical part, which I think is the fun part of it. So first, what we're going to be doing, we're going to be essentially indexing transfer events from an ERC20 contract. Of course, this indexing 20 contract, we got the address already in there, and it's in the Taiko network. And I want you to become familiar with the standard development process, which is the one using the Graph CLI. And then we'll later see how to do this with the Goldsky instant subgraphs, because this way it's just for you to have more tools to develop subgraphs, basically. If you can follow along here, I just put all the instructions here in the deck so you can follow along. But essentially, I'll walk you through the basics, right? Like, first, we need to have a few prerequisites installed. We need to have the Graph CLI installed, so we can go through the Graph CLI development process. Then we need to have the Goldsky CLI, so we can deploy those subgraphs onto the Goldsky platform. And then we also need to log in from the CLI onto our own project. So, whenever we do a deploy, we will be deploying the subgraph on your own project, basically. Now, before we do that, let me just walk you through the basics, right? Like, if you don't have an account on Goldsky, that would be the first thing to do. You can just go to goldsky.com over here. And then if you click on dashboard, you can go into sign up, and then you can just basically sign up for free with an email address, right? And that's going to open up an account, which is on free trial, and allows you to deploy up to 3 subgraphs and 1 pipeline, which is going to be enough for this exercise. Once you do that, you're gonna end up basically in a workspace, pretty much like the one I have over here, where you don't really have any subgraphs deployed, right? The next thing you will want to do is, as I said before, once you have installed the Goldsky CLI, you will want to go into settings here, and then create an API key, which you can do here by clicking on new key. You can call it whatever you like, hit create, and that's going to give you basically a raw string, right? Once you have that API key, you can come into the monitor, into the CLI, and you do Goldsky login. And then you can input your API key here. Of course, in my case, I'm already logged in, so there is no need for me to do this. But you will essentially be doing this in that way over here, okay? So no need for me to do this, but you will be pasting that here. Okay, cool. Now that, assuming that you have all the basics set up, let's get into how to deploy these USDT, subgraph, essentially. So we're gonna go first, as I said, we're gonna go through the CLI process of the graph. And why we do this, just so you become familiar with the classical scaffolding of let's say the set of folders that define subgraphs with the graph, because very likely you will want to become familiar with that development experience so that you are able to read code from other subgraphs in case you want to copy some ideas, or maybe you want to modify a few things and have more flexibility in your own logic. So I'm going to walk you through the basics of it. When you go and do this development process with the graph CLI is going to create a scaffold of folders for you that you will ultimately build and deploy onto Goldsky. Now, three main things or three main files that I want to call out is the subgraph YAML file. This file is where we essentially are going to define the basics in terms of the configuration of the subgraph. Here we say the network, which is going to be Taiko, the contract address, which will be USDT, the blog, etc. Then the schema GraphQL, this is where we define the data layer. This is where we define what's called entities. And so the entities is basically the data objects that we ultimately are going to store based on the information that comes from the events that the subgraph is indexing. And then the mappings is how these two tie together. The mappings is if you are defining here the contracts and the events that you're interested, and these the objects that you want to store, here is the logic in JavaScript, basically Node, where we take that info, do whatever we are interested with it, and ultimately say save onto that object, onto that entity. So these three files, subgraph YAML, schema GraphQL, and mappings, those are the three main files I want to call out. Okay, cool. So let's go into the standard process. The standard process is rather easy, and we're going to be starting off from scratch using what's called graph init. Okay, so what I want to do here is there's a kind of a gotcha, and I'm going to make this a little bit bigger so you can see it. The graph doesn't index or doesn't support Taiko network, right? So because I want you to become familiar with this experience, what I'm going to do first is we're going to be indexing an ERC20 contract, which will be USDT, for example. We're going to be indexing it from the inferior network, from mainnet. So you can see the whole thing. And we're going to be creating that subgraph scaffolding, and we're going to be deploying that. Once we do that, we're going to modify it a little bit so we can point onto Taiko. And that way, we're going to deploy a proper subgraph USDT onto Taiko. Okay, so let's start with the basics. The first thing I will want to do is I'm going to need to have the ABI of the contract which I want to index. And so to do that, I'm going to go into the Explorer. Let me just go over here. And I'm just going to go to Etherscan. Okay, cool. And I'm going to go into tokens, top tokens. And then here I have USDT, right? So what I'm going to be looking for is the ABI, which is going to be over here. I went to contract, and then if we scroll down, we see here the contract ABI. So I'm going to copy this, and I'm going to create a file here, which let's just say, I'm just going to call this ABI JSON. Okay, this is going to be the ABI JSON, and I'm just going to copy the whole thing over here. All right. So now we have the ABI JSON here. And why this is important? Because now we're going to start the graph init command to build the subgraph. And I want to be able to reference this ABI JSON from a local file. So now we go into graph init. And now here is going to first ask us for the protocol. In this case, it's going to be Ethereum protocol, because this is going to be an AVM. It doesn't really matter on here if you choose Subgraph Studio or hosted service. This is where you would be deploying the subgraph onto the graph. We're not going to be doing this. We're going to just use these tools to build the subgraph, but we're going to be deploying ultimately onto Goldsky. So whatever you choose here is fine. It's going to say yes to this one. And then we need to choose a name for the subgraph. So I'm just going to call this USDT. Okay, and then the directory in there where I'm going to create a subgraph is good to be USDT. Then next, we need to choose the network. In this case, as I said, let's go for now to choose mainnet, and we're going to change that later. Then we need to provide the contract address. Contract address is going to be over here. Cool. It's going to try to fetch the ABI from Etherscan, but it won't be able because this doesn't really work. So that's why we have the ABI handy in a local file. So I'm just going to say, no, don't retry. And then the start block, we need to provide a start block to start the indexing. So here, what I'm going to do is I'm just going to choose one block, for example. Let's just take this block. Let's just say no. I just want to translate. No. Okay, cool. And then so ABIs, let's just say the ABI is called ABI JSON. Okay, and then for the start block, I'm just gonna take this last block that we saw and maybe ultimately, a few blocks behind. Then name of the contract is gonna be USDT. And now by default, what's gonna give us the option is to create, it's gonna index the events that it finds in the ABI, and it's going to create entities that resemble those events. So we're just gonna go with that default option for now. Okay, cool, we hit true. And now the graph CLI is creating the scaffolding for us. Let's see. Okay, cool. Add another contract. I'm just going to say no here, and we're good to go, right? Okay, so now here, over here, I'm going to have a new folder. You close USDT, so I'm going to open up. And now we have yes, trust. There we go. So now we have all the files that we created now. So pretty quickly, what I said before, the ones that we were looking into, this is the YAML file that defines the configuration of the subgraph. As I said before, you have the address, ABI, and start block that we defined. By default, we have as many entities as events it finds within the ABI. You can see here the event handlers being created. Now, the GraphQL, as I said before, these are the entities that it has created based on those events. So, for example, if we are interested in transfers, we can see here that we see the transfers with as many attributes as params there are in that transfer event. And then as well, in the source file, we're going to have USDT. And this is where basically this USDT, this is the mapping file. And here is how we define the logic. So that by default, whenever, as I said, whenever there's an event of this type, this handle event is going to take those params and create a corresponding entity and save it.
Hey, Javier.
Yeah.
Sorry to cut you off, but can you just make the text a bit bigger when you're in here, please?
Sorry. Yeah, that's a great call out. Sorry. Okay. Can you guys see it now?
Yeah, that's a lot better. Thank you.
Thank you. Yeah. Cool. All right. So now we have this. So what do we need to do now? Basically, we have all the subgraph all the code being created, right? So all we need to do now is basically build it and deploy it onto Goldsky. So to do that, first we're gonna do graph, and we're gonna do graph build, and that's gonna build our code. This creates the WASM file in this build build folder. Now this is the thing that we're gonna be deploying onto the indexer, right? So over here, the next thing we're going to do here is, now that we have the subgraph, we're going to do the command Goldsky, and let me clear this. Okay, Goldsky subgraph deploy, and we put on a name for it. So I was going to call this USDT mainnet version 1, for example. So we do this and hit deploy. This is going to take those build files, going to take it and it's going to deploy them to Goldsky onto your project, right? So now it's going to give us the corresponding GraphQL endpoint over here. So here we have the GraphQL endpoint, and now we can start querying information from the subgraph. In the background, what's happening? Before we do any of that, I want to show you that if we go to subgraphs, this subgraph has been deployed into my network and its status is indexing, right? So we go over here and we see that it's indexing information of it. I think I'm already able to query some info. So one thing which is pretty handy is if you come here in this left-hand menu, you have the opportunity to build a query object based on the entities that are stored within this subgraph. So if I want to see transfers, I can click here, and I can build that object, query object for me. So I can get the ID from 2, for example, and the value for the first 10. And you see here, I can now gather that info from those events pretty quickly from the GraphQL endpoint. So that would be pretty easy how we're deploying a subgraph using the graph CLI command. Okay, so that's actually one thing which I wanted to show you. Now, the real reason why we're here is that because we want to deploy subgraphs onto the Taiko network, right? So one thing we could do is we can reuse this scaffolding and then change a few params so we can point to an USDT contract deployed on Taiko instead. So to do that, we first need to change the network, right? So network, instead of being mainnet, is going to be Taiko. The address is going to be the following. If we go over here and we go to Taiko Explorer, let's see, Taiko scan, and we go to tokens, and we choose top tokens. Let's go for USDT. We do pretty much the same process, right? We take the token and the address ID in this network, and now the start block, we can choose whatever, maybe this one. Let's just choose this one, something like this, for example. Now the code stays pretty much the same. The reason for it is that, as you all know, this is also an ERC-20 token and it's fully compatible, right? So now, only with those changes, what we can do now, let me clear this over here. We can do now is we can run a code gem to recreate, graph code gem graph build. We redo the code again, and we build it once again. So we do that. And now we have a new WASM files to be deployed onto this network. So now we repeat the process, right? We do Goldsky subgraph deploy, in this case, USDT, and I'm going to call it Taiko. And so now here is going to deploy the same thing. We're going to get another subgraph being deployed onto the network, onto the Goldsky network. In this point is going to be pointed onto Taiko. So if we go back here and do subgraphs, then we're going to see here that we have Taiko, and then we can also start querying information from Taiko. Okay, so as you can see here, we can reuse the CLI process from the graph in order to build subgraphs and change a few params to be pointed onto Taiko to deploy these subgraphs onto Goldsky. Pretty easy way to do that, actually. Okay, cool. Let's look into, let's actually see what else is what we have over here, right? We've seen the standard development process. We've gone through a very simple way to do this implementation. In reality, you may want to do more complex stuff. So for example, you may want to be doing aggregation. So this is an example that I have deployed on here, which if you have access to the deck, you can access this. This is example subgraphs. So let me just copy it. Or maybe let me, yeah, this is good. Let me switch monitors. Let's just see here. Okay, cool. Okay, so we have another subgraph over here, which I've prepared for you. This one, if we just quickly look into it, we will see that what it does is slightly different. You can basically see that here, well, we're only getting 3 entities: token, account balance, and token balance. And we're only looking into the transfer events. Let me make this a little bit bigger as well. You can also see that we're only looking into the transfer event over here instead of all the events from the ABI. If we now look into what else we have, is that another difference is that we have created a different handler, because here we're going to be tracking the account balance for each account, basically how much of that token an account has, rather than just be looking at transfers. So here you can see specific information that allows you to keep track of the from on to address, and essentially whenever we see a transfer, we will remove or add as much of that amount of that token from the existing token balance associated to that account, basically. I think we are running a little bit out of time, but I'll quickly show you how to get this deployed. Pretty easy. What I'm gonna do is, let me just go here. I'm gonna clone this repo. I'm gonna go here. Let's just go Taiko as well. I'll do git clone. Let me just Here it is. Git clone here. All right. Now you can go into Taiko subgraphs. You can go to subgraph. Once you are in there, essentially, just the basics, right? You will want to do Goldsky subgraph deploy. We can call these USDT balance because we are still tracking USDT, but just like having different logic, as you saw. I'll call these 100, for example, and then get this other subgraph being deployed over here onto my project. So there's another subgraph we just deployed. And you will notice that the difference here is that if you go into this left side menu, you will see that now here I can query token balances, which are related into accounts, and they also have specific tokens with it, which is actually the same token, right? Which is USD. And there we go. We can see how much each balance has of USDT. Okay, so this is just another way for you to, I just want to give you some ideas into how you can take existing subgraphs, because there is a bunch of subgraph code available up there. So you can just take it, get inspiration, tweak it a little bit according to your needs and deploy it onto Goldsky, essentially. All right, cool. One more thing which I wanted to show you on the subgraph side, which is pretty cool, is, and let me open this repo app. If I open this repo over here, we were looking into the subgraph folder. There's another subgraph, another folder called Instant, and this is what's called Instant Subgraph, which is a very cool feature. And let me open this up a little bit. These instant subgraphs are essentially a way for you to deploy subgraphs with zero code. Here, Goldsky CLI is going to be responsible for creating the subgraph code for you based on a few params and deploying into the Goldsky network. So as you can see here, it's a lot easier because you just need to provide the very basic info to deploy the subgraph, which is basically where the ABI is and what the address is and the start block. And that's all you need, really. You can complement and do this more complex with what's called enrichments. But at a bare minimum, this is all there is. And you can just go ahead and deploy a new subgraph with this little code. So, and the way to do that is by using the Goldsky subgraph deploy. Again, we will call this USDT instant 1, or let's call it 3 or something. And then pass in from ABI. And then the ABI needs to point to this config JSON file, which contains information in it. So this will be, let me just do one thing. I need to get into that part, instant, exactly. Okay, so I will repeat this now that I'm in the file from ABI and then the config JSON file. Cool. So this will, we will generate the subgraph for you and deploy into the network just like the other one, and we will have a newer subgraph deployed. So this is the easiest way to deploy subgraphs with zero code. We go back here into the project. You'll see that we have a bunch of, let's see. We will have newer subgraphs being deployed onto my, there we go, onto my project ID. All right, cool. So I'm going to rush out a little bit because unfortunately, maybe getting about to, we got 10 more minutes, right? I think. Yeah, I think we got 10 more minutes. So I'll try to rush a little bit. Yeah, over here. Cool. We got a few extra perks, which I'm not going to be able to show, unfortunately. This will be webhooks. So you can basically, whenever a new subgraph is saved, you can create a webhook. A new entity, you can create tags, private endpoints. So I will attach this information, which is over here, onto the deck, so you guys can explore, what's actually very cool about Goldsky subgraphs, which is basically unique points that you can leverage to make your subgraph experience even better. Now, on to the next last section of the presentation, which is calling, the mirror data. Over here, as we saw, subgraphs and indexing, they are great technology, right? Because it allows us to keep track onto what's going on the blockchain in a way that is efficient for us to query. But the reality is that the limitations of subgraphs technology are quite evident as your application grows, and then you need to get to know, you need to meet more complex business needs or requirements. And I just want to call out a few use cases which are very typical as your application grows, right? Think about something like fuzzy search, or think about analytics, or maybe you want to merge off-chain with on-chain data. Like all of that, all of those use cases are actually very, very limited if you're trying to do or satisfy all of them using a GraphQL endpoint. That's you can build technology around it, but that's not going to scale, right? So subgraphs technology is quite an efficient technology for certain use cases, but as you go and start meeting more complex data requirements, that API layer is going to be a constraint for you. So our solution to that is Goldsky Mirror. So Goldsky Mirror essentially are real-time pipelines that allow you to get that information from the subgraph, or let's say from the PostgreSQL database that we talked about before, and you can stream it into the database of your choice. So if you have a use case, for example, that requires real-time analytics, then you can stream that information real-time onto something like a ClickHouse. Or if you want to build a REST API on top of your event data, then you can stream that information into Postgres database, for example. As well as not only doing that, but also you can combine subgraph data with on-chain raw data, for example, raw logs from Taiko, raw logs, which we're going to index soon, etc., as well as other chains in case you, for example, you have a multi-chain application. You can also do this with off-chain data. So if you have a MySQL database or PostgreSQL database, we can also read that data, merge it with on-chain data, and stream it into whatever database of your choice. So as you can see here, there's a ton more flexibility by you being able to skip the limitation of the API layer that the subgraph provides into the possibilities of opening up that information or that data into whatever database or warehouse of your choice. Which this is something that I want to show you pretty quickly how this works. And I will have to show you this in like 5 minutes, I guess. Yeah, so this is done using pipelines. It's rather easy. You can create new pipelines and just clicking over here. And then you got two options. You can choose subgraphs to be the source of the pipeline or raw data. In this case, we're going to choose subgraph. And then over here, you can basically choose as the source of your pipeline one of the subgraphs that we have deployed so far. So for example, if I want to stream the information from balance, I can choose this to be the source of my subgraph. I can go ahead and start the pipeline development process, basically, which is this little wizard in this UI. So if I click create pipeline, I will basically need to input some information, which is going to create this YAML file that officially defines the actual pipeline, right? We need to define the sources, we need to define transforms if we want, and ultimately the sinks. So for sources, I chose the USDT balance subgraph. I can choose which entities I am interested in streaming. So for example, let's say I just want to have the accounts, token, and balance, so basically all of them. And then the resource size, this is the amount of compute that we want to put into these pipelines. So with a small one, it's going to be more than enough for sure for this type of subgraph. Then we need to choose the sink type. And sinks, as I said before, we support a bunch of sinks. In this case, for example, I have direct integrations created towards my NeonDB and as well as ClickHouse. So I have basically the possibility or the setup already created to stream data into this NeonDB, which NeonDB, for those of you who are not familiar, it's basically a PostgreSQL, an online PostgreSQL, which is all serverless, rather easy to play with. And here I have got some tables that I can basically query. So the idea is that I want to stream data my data into my own DB, basically. So to do that, I'm going to go ahead back to the pipeline builder editor, and I'm going to say which I want to use this, which we call secrets. And then this secret will allow me to securely communicate with my database. So as you can see here, as I clicked on my Postgres secret, it was added onto the YAML file. So this is the basics. I can just go ahead and deploy the pipeline. And now in the background, the pipeline is going to be created, and it's going to, we're going to lift up the necessary resources to be able to stream this information into my NeonDB database, basically. You can see here, if I do the following, if I go back over here and I do Goldsky pipeline monitor, I can get real-time information about the execution of this pipeline. So now what's going on is that we are, as I said, we are creating the rare resources, and we're going to start reading at some point from the subgraph data. I'm going to write this data into my PostgreSDB. Because we don't have as much time, I did this previous test before, so you can see what it will look like. Essentially here, I made pretty much the same before. I created Taiko min and Taiko transfer here just before I started the workshop here. So you can see how the information gets streamed into the database. You can expect, basically the same when the pipeline is up and running, but which unfortunately, I'm not sure if I'm going to be able to see it because we don't have as much time. So yeah, that's pretty much it. Mirror, we really see Mirror as the next generation of on-chain data retrieval, but definitely subgraphs as very, very useful technology. But you can find a sweet spot when you're able to combine both. So definitely you should explore both options for sure. Okay, cool. That's pretty much it for now. I kept it to the 45 minutes as promised. There's a feedback link, which I would love if you guys could fill in and provide some feedback for us, so that we can best prepare the next section based on your thoughts and feedback. Also on this deck over here, I've also added all the links that I've been talking about and I've been referring to, so you can have a much easier reference in case you want to build upon the workshop we just went to. Yeah, that's pretty much it. Yeah, I'll stop streaming. Cool, stop stream, cool. I didn't see any questions, by the way. What was it?
Yeah, no, I mean, I've got a few questions. First of all, thank you so much, Javier, for the great presentation. I do feel like I could have learned a little bit more and gone deeper into the mirror aspect of things. I think that that just leaves people wanting more and hoping they're going to dive down the rabbit hole themselves and learn some more about what you guys are doing. Yeah, a couple questions for me is like what like data availability is like a huge aspect of in the blockchain space, like just getting and storing data. And I know the graph has a particular way of kind of making that data public and incentivizing people to do that. What is Goldsky's kind of perspective on that? And can you like expand on that topic a little bit?
Yeah, definitely. Well, I mean, data availability is quite a conversation by itself, but there's a very cool thing that I'm very proud of, which is called Index XYZ. And basically, this is a public good, if you call it. Just as did you see these pipelines that we were creating? Yeah. Basically, we've also, we got agreements with some chains, and we got internal pipelines, which are basically they have a lag of 10 minutes, but they are live streaming with a lag of 10 minutes. This information onto basically repositories which are public. So any person who wants to maybe, for example, see raw logs, transaction receipts, and traces of many chains, they can easily pull this data for free by visiting this index XYZ page. So we do that for the community in a way, right? That would be one way to put it. Now, on the data availability when it comes to layer 2s, I think something which is very interesting is we try to make the data sets in a way that are very, very useful for our customers. So the amount of information that we have in these receipts, for example, also speaks to the L2 settlement, or how much gas was consumed, or both on the L2 side as well in the L1 side. So the most complex pipelines that we see are the ones which are able to essentially combine multiple chains into the same pipeline definition file and stream that in the same database in a way that is cohesive to their use case, which is most of the time is going to be analytics, basically.
That's awesome. That's really cool. I was just actually doing a project that wanted to analyze the gas expenditure from different addresses. So it sounds like Goldsky would have made my job a lot easier, because I had to go kind of block by block and gather it all myself.
Definitely.
So that's really cool.
Yeah. Maybe let me write. It would be good for me if I put on index XYZ here, if you guys can share it as well. In case anyone, as I said, this is for free, basically. Anyone can just download that data. We have an agreement with Cloudflare by which we can host the data for free, basically.
And is Taiko data there yet?
It is not. We are actually working with you guys to get that data in. We need to. Today, we looked into how to stream subgraphs deployed on Taiko, and create those for the pipelines. But very soon, we're working on ingesting data sets like rollups, blocks, etc., so that you can also get all that info directly as source to the pipelines.
That's awesome. Yeah, we gotta work towards getting our Taiko data up there, and I think we can work that magic behind the scenes for folks.
Yeah, that's there.
Yeah, one more question for you is, like, what are you guys looking for in terms of projects coming out of here building with Goldsky? Do you have like a specific use case, or is it like super open, or some of the criteria that you're going to be using to judge projects?
Yeah, that's a good point. Like, honestly, we've got customers all around in terms of use cases, like, because we are a data layer, right? A foundation layer. So we got customers on the gaming side, on trading application sides, even Polymarket as well, right? The Polymarkets, they use a ton of our pipeline technology, which is gambling. So the use case itself, it doesn't really have to be specific to, let's say, for example, gambling. It doesn't have to be like that. I think we're more interested in seeing how people really leverage this technology, mirror and subgraphs, to create something cool, or to create something useful, right? If you are building a trading app and you have deployed a subgraph, and then you're using that with a pipeline to feed the real-time stream of the information in your trading application, that personally, I think that's actually a very cool use case. So yeah, I think like anyone who is able to combine as much information that we have provided so far about the tools and can use it in a very creative way, definitely will win points for sure.
Awesome. All right. I think we'll leave it there for the time being, but anyone listening in and watching in, you're welcome to come over to our Discord, and there's a dedicated channel there for the Grand Factory Hackathon. Javier will be popping in there, as well as members of the Goldsky team, to make sure that you're well taken care of. Yeah, I think I think that's about it. Do you have any closing words for us, Javier?
I know. Just thank you so much. Very excited to see a lot of builders in Taiko. And yeah, let me know about your feedback. If you would like to have a deeper session on subgraph or mirror, happy to do so. Just let me know for sure.
Great. Thank you so much.
Thank you.
Okay. So we're going to be shifting over into our next session here. And this is going to be another session run by one of our Bounty supporters or Bounty sponsors. And I didn't mention, or I mentioned at the beginning, but I didn't mention as we were closing with Javier, they have a 3K bounty. You can go onto the DoorHacks website and read in depth what their bounty is and the criteria and how that bounty is being broken down. But likewise, we also have Hemera that is coming on and putting up a bounty as well. And so we have Shu from Hemera Protocol coming on to talk about ACI, their account-centric indexer. And so I'll just kick it back over to you to take it away.
Yeah, thank you for your introduction. So hello, everybody. Thank you for joining us today. My name is Shuo, and I am co-founder and CTO of Hemera Protocol. So today I think I'm going to give you a brief introduction of what Hemera Protocol does and what exactly is account-centric indexing. And then our DevRel, Shantanu, will go over more practical use case and examples. I think in the end, we will still have time for Q&A, and you can feel free to drop us any questions you want to ask. Okay, so let's begin. So first of all, I would like to talk about why we create Hemera Protocol. I think I still remember a few years ago when we first get into the Web3 world and started the company, and we are building a CRM tool for DApp, and especially the NFT projects. And they were very popular at that time. I think we spent lots of time finding different APIs, RPC calls, and all different vendors provide different certain piece of data. And we try to merge them all together to build a tool. And of course, it's very not a very pleasant experience. I believe many of you may also have the same experience. No matter you are a DApp developer or a protocol developer, or even just a personal developer, you will always find it's very hard to get access to full on-chain Ethereum data. And what's more, I think even if you can get transaction level data or event log data, and it's still very hard to aggregate data into the account level. You can also call it user level. I'm not sure how many of you have experience with Web2. I think every single company in Web2 have their user concept, but this is the missing part from the Ethereum world. And I think what's more, I think recently you already see that hundreds of L2s goes live and DApps become more and more complicated. They create a complicated data on chain, and which make the read of Ethereum data even harder. And everyone is saying that we need more users from Web2, but apparently reading blockchain data is the major blocker. I think that's pretty much why we invented the Hemera protocol. I think the Hemera protocol, which is also the account-centric indexing, is here to address those issues. The Hemera protocol is a programmable protocol, and it abstracts low-level on-chain data and those smart contract logic, and utilizing the user-defined functions to express new assets and contracts. And this provides real-time updates and enable developers to build a more efficient way and help Web3 team to save lots of time on reading blockchain data. And to explain a little bit more detail, I think you can think of right now, if you use the account-centric indexing, and you will have a user table for all the Ethereum address. I think it's very similar to the logic in Web2 companies like, for example, Twitter. I think in Twitter's user table, there are features like your email handlers, birthday, and it also can have statistics like how many tweets you have, how many followers you have, and even more sophisticated use case, you can have, for example, how many people view your Twitter today, and how many followers you gain or lose in the past week. And that's all belong to the your user table, your user-centric data. And for our use case, if you have a user table in Ethereum world, and features can be, for example, your assets holdings, or it can also be your registration history to ENS, or your forecaster followers, or even about tradings. For example, how many trades you made on Uniswap, and how many volumes you have, and even the P&L you have. All those information can be aggregated into the user level by using Hemera protocol, which is an account-centric indexing protocol. And I think the cool part about account-centric indexing is that right now you can add your own features. You don't need to use the of course, we have lots of existing features, built-in features, but you can also create your own features and add it to the user level. You can define your own data structures, and you can write your own code. The code here doesn't mean you have to write everything from the scratch. I think you can actually, we already set up most of the framework for you. We already stream all the all the blocks, transactions, and logs to you. And the only thing you need to do is to read the basic data and write your transform logic and generate the data you like. That's all you need to do. And you should be able to run and rerun and backtest with historical data before it actually goes live. I think this part, Shantanu will talk about more later. I think there are lots of benefits you can get from using Hemera protocol. First of all, comparing with other vendors, I think Hemera protocol is by default real-time. Since the indexing is along with other indexing work, such as blocks, transactions, you are indexing all the things together. So everything you have will by default be real time. There will be almost no delay. There will probably be a few seconds delay, but compared with other tools, for example, Dune, it will be much more real time. I think also it will be automatically aggregate everything into account level. I think the account level will help you in majority of your data use cases. No matter you are building, for example, you are building a DeFi dashboard, you may want to understand each user's behavior. And if you are building a social app, you want to understand different users on your social platform. The account level data can also help you by the most. And I think with the account-centric indexing, it actually covers lots of users use cases on the blockchain. I think from the basic blockchain explorers to, for example, your Web3 wallets, and to your, for example, ecosystem dashboard, and even a more complicated use cases like anti-CBO detections and power user analysis. I think everything on top of the data can be built using the Hemera protocol. And also we are continuously building protocol. We are not stopped here. We are actually adding lots of features to the Hemera protocol every day, every week. And I think there are two aspects we are focusing the most. First of all, we want to, you can call it modularity, but you can also call it, for example, abstraction. So we want to make sure the user interface we expose a generic interface, and every single developer should be feel very easy to pick up, and they can easily add their own logic and create their own features. On the other hand is the performance. I think you may also heard several chains, for example, Monad, MegaEase. They claim themselves to be high performance EVM chain. They will have up to, like, let's say 10,000 transactions per second. If that's the case, the indexer will, of course, need lots of performance optimization. That's another aspect we are working on right now. I think lastly, I think this is all the ecosystem partners we have. And one thing notable here is that we actually start to work with Taiko since testnet. And our social scan explorer is live, I think, since the first day of Taiko's mainnet. And right now, we are still running Taiko's nodes, and we have the Taiko explorer on social scan. And we also have a set of APIs with the full Taiko's data. If you want to use that, we can also get you access right away. Yeah, and of course, our indexer is ready to use. If you have, I think you can just apply Taiko's public RPC, and you will be able to index any smart contract on Taiko. I think there are a few useful links. I think we have the website, which will talk about our, I think, external facing product. I think that's pretty much for blockchains, for DApps. I think if you have that, if you want a professional service, you can just go to our website and check. And I think the most important piece is the doc and GitHub. I think our Hemera protocol is open source, and you can clone the project right away and start to run, I think, on your local laptop. That's all open to you. A few other links. I think we have Twitters. I think Hemera protocol is our main Twitter. We also have a Twitter called Social Scan. Social Scan is an application on top of Hemera protocol. I think it's also built by our team, but it's a more application, user-facing application. I think that's all from my side. I will hand over to Shantanu, and he will go over the other part of the workshop.
Awesome. Thank you. Thank you so much. I think that was a wonderful walkthrough. So I'll quickly share my screen, if you don't mind. Okay, perfect. So hi, my name is Shantanu. I am a part of the DevRel team at Hemera, and today we'll be walking through a very exciting thing called building UDFs for our dApps. So essentially, what we'll be doing is we'll be running our own indexer network. We'll be writing some custom code, and we'll be indexing ES721 on a Ethereum or a Taiko network. So it's very easy, very sweet, and we can get started quickly. But before we move on, there are a few things that I would want to highlight. One is, I mean, of course, Shuo has mentioned and spoken briefly about Hemera protocol, but yeah, a few pointers from my side as well. So essentially, Hemera protocol is an account-centric programmable indexer network, and it helps blockchain developers build faster applications and get more real-time data on-chain data. Yeah, so let's talk a bit more about, I mean, I'll throw some light on Hemera indexer as well. So specifically, Hemera indexer is the open source code that's available on our GitHub, and you can spin up and run your own indexer network with a custom built code. And that code that actually triggers a particular function, it's called UDF, user defined functions. So the whole goal is you define a specific triggers, you write code depending on what are your expectations and what are your needs are. And then that code takes care of the whole indexing part of the game. We'll have a look at it. I'm just explaining the flow as of now. Any EVM compatible chains can be done, and in this case, we can also index Taiko. So you can use any public RPCs that are available, and you can get started ASAP. So quick features of our whole indexing network. One is you can export entities like blocks, transactions, logs, tokens. And when we say token, I'm talking about multiple token standards, EFS20, 721, 1155, etc. So in this tutorial, in this workshop today, we'll be walking through 721 and looking at how the data gets populated in the database. There are multiple options for output. One is the Postgres is built in the stack. So you get all the data stored in the Postgres DB, and you can view the data directly through the database itself. There are two more options. One is you can get the JSON, and the other you can export the CSVs as well. Depending on your use case, depending on your needs, you can modify the output formats as well. moving next, setting up is very, very easy. So first things first, we need, two things that are really essential is a system on which you want to run the network. And second is the RPC node. So, you can get the RPC, you can host your own RPC node, or second, you can get an RPC URL based on the chain that you want to track on or put your UDFs on. So in this case, we'll be putting out Taiko or Ethereum, whatever your needs are, you can put it down. Hardware requirement, there are a few things that we need to keep in mind. One is we need a 4-core CPU. Second is 8 GB RAM, 8 GB memory to power the whole indexing powerhouse that we have built out, and SSD storage to make sure the whole indexing part is sweet and swift, while you are building our applications. But the data size, the size of the SSD depends on the type of application you're trying to build or the type of data that you're trying to index. On our documentation, we have this. I'll just quickly share this documentation. If you can add this to the chat as well. So in this documentation, in this particular repository, you can have a look at on the data space that is required. And yeah, you can spin out your own node. Perfect. So I think we'll get started. We'll quickly have an overview about how to run this, how to get started, and all of those things. Before we begin, one last thing that I would want to highlight is configuration of our environmental variables. This is the most essential part because without this, the whole network might face some difficulties in getting configured. So there are a few things that we need to take care of. One is the RPC URL, which goes in the environmental variables file, env file, which we call. Then we also have the blocks from which we want to get started with. So we have mentioned somewhere around 200K block number, and from starting from that block, the indexer network will start indexing the data and putting out based on your output format. And then you have a set of more configurations like PostgreSQL DBs, credentials, and etc. things. So yes, I think I'll quickly share my entire screen and I'll showcase the whole working on how to set things up. Okay, perfect. So this is a repository which is called Hemera Indexer, and in this we have like a specific use cases that we have built out. And in today's example, we'll be looking at the mint date for each token within ERC20 smart contract. So the code is open source. You can check this out right after the session as well. So first things first, you have to clone this repository. I have already cloned the repository and it's there on my system. And then you have to just get into the Hemera network indexer and then get into docker-compose. So this docker-compose, the directory, it contains like two set of files. One is a docker-compose.yaml, which is Docker composition logic that is written out. All of the services that needs to spun up to run our indexer network is configured in this file. I would encourage not to actually tweak this file. This is an essential file which takes care of all the rendering, all the services that runs behind the scene of our indexer network. Next file, if you can see, there is a Hemera indexer.env, which holds all of our environmental variables. So to quickly check that, we'll do nano or vim, whatever is preferable. We'll just quickly go here. First thing, if you can see, I have a mainnet RPC.
Shantanu, sorry to interrupt. Can you just zoom for your terminal and all the
sorry.
Yeah, thank you.
Okay, perfect. Yeah, so for the provider URL, this is the RPC URL that we are providing here. If you can check, I'm using Infura here, but you can use Anchor, you can use QuickNote, depending on your use cases. Then you have the start block from which you want to start the indexing process. So we have mentioned somewhere around 200K. And you depending on your use case, you can tweak it out. And then we have the Postgres URL. This is, we can generate it pretty easily. Then you have Postgres details, which is username, password, and DB details. So yeah, these are the essential parts that are required to start the whole indexing network. And once you do that, just go back to the terminal and type Docker. So I'm using it on a Mac OS, and if you're building a project internally or locally, you can use Mac OS. You can use your own. You can host it on a VM as well. But if you're hosting on a VM, on a Linux-based VM, make sure you use sudo command because it requires root access to run all of those services. again, there are two ways to run the whole of our services. One is the Docker way, which is easy and quick to get started with. The other way is to build from scratch. So we have a Python whole repository, the Hemera index repository. You can just build it in the traditional way and get started as well. If you want to tweak something, if you want to check, as Shaw was mentioning, backtrack few things, see how things are working across, or what services or what functions are being called internally, I think that is the best way to get started with. But if you just want to, play along with the UDFs, configure something of your own, and then get started, I think this is the best way to do that. So the next command that we use is docker compose up, and it should take a few time. And perfect. So this has started up based on all of our details that we have. Now, I will let this run for some time to start the indexing processes. But in the meantime, let's quickly browse our code and understand what are the things that we need to inculcate to make sure to write our UDFs. So in that case, at this point, in this case, we are writing a few. I mean, as we mentioned, right? We want to extract the date of a particular mint of a contract that has been done, ERC 712. So first is we write the token mint job. So this is like a function that takes care of what token or what contract you want to track out, and what are items that you want to track out. Let's say I want to track out the date, I want to track out the transaction ID, a few more items that are there on chain, and you want to track that out or index them up. You can actually describe all of them here. So yeah, so as you can see, I have a token mint function which is calling all of those essentials, which is block stamp, token ID, transaction hash, etc. So this file, we need to put that out inside a module. So if you go inside modules, then you need to go inside customs. You need to create a custom folder, and inside that, the UDFs, which is the user-defined function for which you want to run things out. So here it is ERC712 token mint. And inside that token file, we have a job file which takes care of all the extraction side. This is an essential part, and all of these code is open source. Right after my session, I'll share the code as well, and you can have a look at it as well. Next is a token mint file which goes under the models, which is basically you're defining how would the whole data table would look like. So end of the day, we are putting this data somewhere, right? It could be your output, it could be your Postgres DB, or it could be a JSON file. So, but you need to define the structure of the data in which you want it to, you want it. So one is, I'm putting down my table name. If you can see, I have a class which defines a table name. I have a couple of parameters, couple of columns that I've created: token address, token ID, block number, block timestamp, transaction hash, and a few more time-based and a Boolean as well. So these are a couple of things that is essential because you need a structured data, right? Unstructured data converting into structured data, that is the case. That is what Hemera is for. So this is an essential part, and this file goes right inside models. So you just need to go to the indexer file, indexer repository. In that, you'll find a folder called common, and inside common, you'll have something called models, in which you'll have all of these files. Then finally, you need to define a data class, and all of these things are on our repository as well. If you want to read more about it, if you want to know more about it. So this is.
Sorry, again, we need some Zoom. Yeah, thank you.
I think something is wrong with my system, but yes, yes. So this is a data class that you need to write to make sure all of those data is being tracked out. And yeah, I mean, after this is done, you just need to run the network. I'm already running it. So yeah, the network is being running out. But yeah, we'll quickly check for the DB. So I'm just connecting my Postgres and see if this works well. Okay, perfect. So there are a few things that I wanted to talk about. So one is what I'm showing you right now is my Postgres DB, which is running inside my Docker network. So this DB actually consists of the table and as well as the data that we're trying to index right now. So we'll have a quick overview about the data. So if you look at ERC712 changes, it's still being indexed. But yeah, these are few records that are being done. And if you look at the ERC20 transfers, ERC115 transfers, based on the contract that we have provided, it is tracking things out, it is dumping them down into the DB. Now you have two options. And if you want to integrate this data or if you want to use this data in your application, how do you do that? Option one is you use the Hemera's pre-built APIs, which already comes packaged with the indexer node that you're running or the network that you're running. So that is one way to do that. Or the other way, you already have the data dumped into a Postgres. You create, I'll just zoom in again. I don't think I can zoom this particular application. But yeah, for if you want to use this data directly into your application, let's say you want to connect, you can just connect this using any of the Postgres libraries for your native application and start the process. So yeah, I mean, this is how the whole indexing part or UDFs part works. So these piece of code, these three files are essentially UDFs, user-defined functions. We are defining a set of functions for our indexer network to perform these XYZ actions. And based on that, it is indexing the data, chunking it out, and putting out in the output that we define. So yeah, this is the whole quick gist about how things work. Yeah. So I'll just again share my workshop screen. Okay, perfect. So I'll share this repository as well. You guys can have a look at it. And yeah, so turning out again, what is UDFs? UDFs essentially allows users to create their custom functions for Hemera indexes. UDFs essentially are the custom data operators, and they don't really play along with the existing core code that's there for the network. So you don't have to modify the core concepts or the core protocol code. You just have to put out these functions, put out these piece of code, and you're all good to go. To get started. So if you want to get started with all of these processes, very easy. You just need to get started understanding what ACI is, account-centric indexings, understand how the whole protocol things work. The link to the docs is docs.hemera.com. I'll drop this in the chat as well. So you can have a look. And if you have any questions, you can reach out to me on at @the coderpartner on Discord. I'm also on Taiko's Discord. Feel free to reach out to me if you have any questions. So yeah, that's all from my side. Let me know if you have any questions. I'd be happy to answer.
Classic.
I think you're on mute.
Yeah, classic mute error there. Thank you so much for the workshop. I'm not sure if Shuo is still with us, but just a couple quick questions from my end is just like I asked the Goldsky team is, are you guys looking for anything kind of in specific from projects? Do you think it would your technology is specifically suited for a particular vertical, or or like the judging process? Like, what are you guys kind of looking for?
Yeah, for sure. Yeah. So a couple of things that we are focusing on as of now. One is you can build exciting applications, and as Shaw mentioned, there are endless possibilities. But few options that we are looking at is DeFis. So if you want to build a DeFi dashboard, if you want to build your tracking on top of any specific DeFi protocol, you can do that using Hemera. That is one exciting field that we are looking at exploring as of now. GameFi, SocialFi, and as well as decentralized identities. These are specific sectors or sections that we are exploring, and we would really encourage focus for people to build something out of these things. And in terms of judging criteria, of course, one is you need to use Hemera, and second is you need to make sure everything is live, fetched out with the node that you're running or the UDFs that you have written, and making sure the code is open source so that a team can review and put out their thoughts. But yeah, these are a few rough ideas. I think you can find all of these informations, on the Dora Hacks page as well. So yeah, that's just a quick round off.
Nice. Is there anything else that you would want to add to that? Sure.
Yeah, I think we are. I think in recent weeks we are heavily spend our effort building use cases on top of Hemera protocol. I think no matter you are DeFi or you are SocialFi, GameFi, anything you can, as long as you use Hemera protocol and you write use case on top of Hemera protocol, I think you will be a good example of for us. I think we will be able to. I think it will be part of the bounty program. I think you are eligible for the bounty program.
Awesome, that's great. Yeah, I think that covers everything. I'll just take a quick look to see if there's any other questions in the chat. Yeah, I think that is great. Yeah, so just to kind of recap, we have Goldsky and Hemera both tackling indexing in different ways. So the technology's open there for you guys to use in your projects. maybe there's a way that you can use both of them in your projects and kind of qualify for both bounties. But yeah, this is bringing our first workshop session up to a close. For all of those folks that are tuning in, thank you very much for coming. This will also be this has been recorded and will be posted later on, so you can go back and take a finer look at all of the details of the workshops and best to build your projects the best way. And like everybody has said, if you need more help, come on over to our Discord, reach out to us. We're here to capture you and help you along the way. And lastly, thank you so much to the DoraHacks team, who's been helping us organize all of this and is our main platform for the hackathon. And that's going to be the platform in which everybody submits their builds and signs up and does all of that great stuff. So definitely go check out the hackathon page if you haven't already. And yeah, I'll kick it back to you, James, to see if there's any last minute kind of housekeeping that you want to talk about.
No, just a huge thank you to all the speakers today and to everyone for tuning in. The link for the DoraHacks hackathon page was in the comments, so click on that to get all the full details of the hackathon. And just a quick note about submissions: you can submit your project and then update it later. So if you want to get it submitted early on DoraHacks, you can do that just so it's there on the page, and then you can keep updating it up until the deadline. So feel free to do that if that suits you. But yeah, super excited to see what everyone builds.
Yes, likewise. And we are going to have more of these sessions coming in the next couple of weeks. We have some of our internal team members are going to be giving you guys some business talks and some grant prep talks. So keep an eye out for the schedule for that starting next week. And with that, I thank you everybody again for being here, and we will see you hopefully in the Discord.
Thanks, everyone.
Take care.